Right. So we're looking at some chemistry topics here. Looks like all these, or most of this, is, well, maybe not most, a lot of it is related to organic chemistry. So let's look at this a little bit more closely. I'll just move this up here. So, right, let's lock that as well. I'll get a highlighter out. So, crude oil. We probably heard of what crude oil is. It's stuff that we dig out of the ground and we can get petrol from it and so on. It's actually a mixture. So it's made out, as it says, made out of animals that have died millions of years ago, and it's a mixture of different liquids. And you can separate it using something called fractional distillation. In a nutshell, fractional distillation, what you do is you heat it up, heat the whole thing up, so as the majority of it boils, and then different elements, different parts of the mixture, which we can call fractions, are condensed at different points on the uh, fractionate on the I forgot the name of the fractionating column. It's something column, something like fractionated column. We'll get a picture of it in a moment. Um, Now it talks about then it goes into what is an alkane. It most likely will refer to alkene at some point as well. Doesn't seem to be that. That's quite surprising. I will talk about it as well because I would have thought you need to know that as well. So let's dip into alkane and alkene then, and then we'll go back over crude oil. Um, Essentially, everything in organic chemistry is related to the carbon atom. So a carbon atom is in group 4, which means it's got 4 electrons in the outside shell, and that means it can share 4 times, and because it has a space for 4 electrons, so it would have 4 bonds. Okay, so I'm not going to do dot cross diagrams for this because we're going to sort of skip over that, but it does link with this. However, you don't need to know dot cross diagrams to do most of the things, if not all the things on in organic chemistry. But if you do, if you are a bit unfamiliar with that, I would look back over covalent bonds and ionic bonds and look at dot cross diagrams. In any case, carbon has got 4 bonds, so I could so I draw the C and I draw these sticks which represent the bonds, and then I could stick things on the end of them, stick other atoms on the end. I could stick another carbon on the end, for example. If I did stick another carbon, that carbon would have 3 of the bonds. The bond is shared. It's just a place where this is just where they're doing some electron sharing. Now let's look at the other main important main element that is involved in organic chemistry is hydrogen. Hydrogen has got 1 shell, which means so it's the very first shell, and that can only hold up to 2 electrons. In that shell, it has 1 electron, so therefore it has a space for 1 more, so it has 1 bond. So that means that I can take my hydrogens and I could stick them on the end of this, and that is now that bond is now satisfied. The carbons, the hydrogen has now got enough bonds, and so has the carbon, and I could put all these around, and I could make a complete molecule. I could keep on increasing the size of this molecule by changing that hydrogen to a carbon. So let's see if I can do that with a few Miro skills here. I don't know. Let's see what happens. Oh yes, I need to delete that first, don't I? So then I have to make sure that I fill all the other bonds. But I could keep going on, and I could have a big long chain, or I could have a short chain. The shortest chain of this kind of molecule that we're looking at here, this kind of what we can call a homologous group. Okay, homologous group. In other words, something that follows this kind of pattern. Homologous. Yeah, homologous group. And this homologous group that I'm drawing, when I keep adding the carbons and so on, this is called an alkane. These are alkanes. So this particular alkane is called propane. So the ane at the end is telling me that it's an alkane, and the prop is telling me how many carbons there is in that chain. So you can have one, and then you could have one carbon would have, like, imagine I draw hydrogens on each one of those. That would be CH4. So one carbon would be meth, and if we're talking about an alkane, it would be methane. 2 would be eth. 3 is prop. 4 is bute, and it gets a little bit easier. 5, like pentagons, is pent. 6 is like hexagons, is hex. So this could be methane, ethane, propane, butane, pentane, hexane. 7 is hept. I'm going to pause the video and just double check that. I'm pretty sure it's hept. Yeah, heptane or hept is the 7, and then 8. I'm not sure how high we got to go, to be honest. I'm going to go up to 10. Oct. 9 is non, and 10 is decane. So if it didn't, so an alkane is a single is a chain of carbon atoms with hydrogens on all the spare bonds, and simple as that, right? So let's have a look at what would the formula be. Well, in this case, this propane formula, this is C3H8, isn't it? Now, if we imagine what would happen if we keep on sticking more and more hydrogens onto these, or changing the length of the chain, you can see each carbon has got a hydrogen on each end. So you're going to have so it's going to be, for whatever amount of carbons there are, so we can say n amount of carbons, there are going to be 2 times as many hydrogens, but then there's also the 2 at either end as well. So the general formula for alkane is CnH2n plus 2, which it has here. So what about alkenes? I mentioned alkenes earlier on. So alkenes are different. They are spelt very similarly. Instead of that A, the second A, it's an E. So alkenes. Alkenes have a carbon-carbon double bond. They always have that. We can call this the functional group. The functional group is what tells you that it is an alkene. And you'll look at some other types of organic compounds, and they will have different functional groups. For example, you can have alcohols, which have an OH group on them. Okay, that's attached to a carbon. That's an alcohol. You can, I won't draw them all for now because I don't want to go too far on a tangent. But you can have alcohols like that. You can have carboxylic acids will have a different functional group. You can have an esters. You can have what else? There's a few more. I can't think of them too many more right now. Anyway, so that's a functional group. The functional group is the thing that tells you that it is whatever homologous group it's from, and it's from a homologous family. Homologous group of molecules. So let's see, what is the smallest alkene you can draw? You can't actually do one with one carbon because it needs to have another carbon to do a double bond with. So now, if we were to stick hydrogens on the rest of this, notice that each carbon already has 2 bonds. So I can only give 2 more bonds to each one, like that. So the ene at the end of alkene tells me the ending of this name, like alkane tell me the ending of the other one. So propane, methane, ethane, propane, so propane, butane, pentane, hexane, heptane, octane, nonane, and decane, because they're all alkanes. They would have single bonds, and there'd be just a chain of carbon atoms with all the rest of the bonds filled up with hydrogens. This is a chain of carbon atoms with, well, in GCSE, one double bond, but you could actually have more than one double bond. It would still be an alkene. It would just be called. It would just have a more complicated name. So, yeah. So this one would be where it's got 2 carbons. So it's eth, and it's got a double bond. So it's an alkene. So it's ethene. Now this is where people make a mistake. They think, okay, so propene is going to be like this. But no, it could be like that. Like I said, it could have more than one double bond, but in GCSE you just do one double bond, generally speaking. In GCSE or not, you would generally speaking do one double bond. But when you get to A level, you'll learn that you could obviously have more than one double bond. In fact, you can have a triple bond. If it was a triple bond, it wouldn't be an alkene, it would be something else. But at GCSE, we draw one double bond. So make sure not to draw one there, because that would now give this carbon 5 bonds. This carbon's already got 2, so I draw 2 more there. Okay, so what would be the general formula? So earlier on we did the general formula for an alkane. What would be the general formula for an alkene? Well, it's still got, if I imagine we had lots and lots of them, there'd be 2 of these carbons would have 1 less bond, but the rest of them would be just like the chain of an alkane, and they would still have, so imagine we got n lots of carbons, and then you'd have each carbon would have, most carbons would have 2n, so 2 lots of hydrogens on each one. You'd have the carbons at the hydrogens at each end, but then so you'd have that, but then you'd also lose 2 hydrogens because 2 of the carbons would have 1 less bond available. So it ends up just being that. So the general formula for an alkene is CnH2n. Easier to remember, but more difficult to understand why it's that. And this one is harder to remember, but easier to understand why it's that. Anyway, so they're alkenes and alkanes, and that's the first thing you really learn about when you learn about organic chemistry. They're both hydrocarbons because they're made out of hydrogen and carbon. Both made by covalent bonds because they are a covalent molecule. We don't need to learn that fact. If we know what a covalent molecule is, we already should know that because they're made out of non-metals, so non-metal atoms. So it's a covalent molecule made out of covalent bonds. So what else? Well, what about crude oil then? Let's get some pictures of crude things to do with crude oil. Okay, so I've got a fractionating column here on the left, and I've got the first 4 alkanes here on the right, and we've got different types we've got the sum formula. I don't think that's what you call it at GCSE. I think it's just called the molecular formula. It tells us what is in the formula, how many of each atom there is. We've got the structural formula, which draws it all out. You got the half structural formula here. Again, this is not coming up at GCSE, but it's a way you will use it a lot more at A level, and it's just a way of kind of giving you most of the information, and you would have to work the rest of it out. So you can probably see how that is kind of like that, and yeah. Anyway, the main point I want to talk about is the fact that as you go down this, as the carbon chain gets longer, then you can imagine the individual molecules will have a stronger attractive force from one another, it's going to take a harder work to separate them, because there's a longer. Let's imagine we draw a long chain here. Let's say that's like, if we zoom in on that, we would have like, I don't know, 100 carbon atoms. And if we had another one sort of connect nearby, then there's going to be lots of attractive force, because they're going to feel these van der Waals forces, which is essentially intermolecular forces between each molecule. And this is going to make it harder for us to heat them up to the point that they're able to flow past each other and eventually able to move around as a gas. So smaller molecules will have a lower boiling point. This is going to be a low boiling point here, and the larger molecules will have a higher boiling point. So now these aren't the only things that the only elements that crude oil is made out of. Crude oil is made out of a lot more elements than this, and much more complicated ones actually. You may know that when you burn crude oil, you get a lot more than just carbon dioxide in the air, but you get other substances which can cause acid rain and so on. But at a basic level, we can just say that, let's imagine we just got short molecules, long molecules. And short molecules have a low boiling point, and large molecules or long molecules have a high boiling point. So what would happen then if we take all this crude oil, we heat it all up, and it gets so hot that most of it is now in gaseous form. Most of it is a gas. Well, all of it would be a gas apart from this one here, bitumen. Bitumen has such a high boiling point that it's actually, we don't end up boiling it when we use this process. We heat it all up to 350. It all boils apart from bitumen. So that means that the only liquid would be bitumen, and that would float down. That would be gathered around here, which means we've now separated it from the rest of the crude oil. As the rest of the crude oil that has been evaporated starts to rise up, it actually gets cooler. This is where it gets a bit, and notice it says here, hot at the bottom, cool at the top. That's something that causes some people some confusion, because they know that heat rises, and we think about hot being at the top, cold being at the bottom. But remember, we're heating this up, and so it's going to be, and it comes in at the bottom, and which means it's going to be hotter at the bottom because that's closer to where all the heat is, and as it gets further away, it's going to cool down. So the first, so basically, the higher up it gets, the cooler it gets, and the ones that have the higher boiling point will turn into a liquid sooner than the ones with the low boiling point. So fuel oil has still a fairly high boiling point, which means once it gets to this height here, it will. So a boiling point is it would be the same as a condensing point, right? It's the point at which it goes from liquid to gas, but it's also the point at which it goes from gas to liquid. So we're in gas form. As it gets up to about here, it gets a bit cooler. I don't know what temperature. Let's say 325 or 300 or whatever. And now it reaches the condensing point or the boiling point of fuel oil. So it turns into a liquid, and this means it can essentially get collected and dribble off over here. So the rest of it will carry on floating up as a gas. And the next one to condense would be diesel oil. I don't think you need to know the names of all this. You just need to understand the process. So as you get further and further up, it gets cooler and cooler, and the substances that had the higher boiling points have already been condensed off and collected at the various points, and eventually it gets all the way to the top. And the gases that were in the crude oil, they would never, they were already gas at room temperature. So we get to like 25 degrees C here, and just slightly hotter than 25 degrees C, petrol will boil, or So it condenses at this point here, and then as it gets cooler, we now no longer have any petrol in the mixture, and we collect the gas at the very top. So what I'm gonna do, I'm gonna post a little video here which will explain it even better than I did. I don't know how well I explained it there, and I'll also give some links to my database, which will allow you to find some useful resources and exam questions on this topic. So I'll just pause the video there. Okay, so I've got a link here to the organic chemistry section of my database, and if we look over it now, there's a video here that shows you how to navigate all of this, but let's look inside of here. We have some related subtopics. As you can see, one's a biology topic because you study DNA when you study DNA in chemistry, and that relates to organic chemistry. And so we've got some alkanes and alkenes. We have 9 resources available there. You can see on the right hand side. We've got GCSE and A level, and we've got some questions and revision notes. We go down, we've got some crude oil stuff here. We've got some questions and answers, and they're at GCSE and A level. Don't currently have any simulations there. There obviously will be a video appearing in both of these sections now, because the video that I'm making right now will be saved in this database as well. So let's have a look what we've got inside the alkanes and alkenes. So we click on that, and then we open it as a page, and let's make that full. It should already be full width, but I'll just do that now. So these are all the resources we have for this one, and yeah, we've got some GCSE ones here. And we got some quite nice revision notes from BBC Bitesize, and we also have some from Save My Exams. Save My Exams is pretty good, and the good thing about Save My Exams is okay. It does have, okay. So unfortunately, my Chrome has set up some weird firewall, but let me just open it up in Edge. So I'm not a big fan of, but I'll do it anyway. Let's just click there, copy the link, and go there. Okay, so here's a load of stuff on alkanes and alkenes, which I think is pretty good. I used this recently, and we've got some. If I click here, will that take me straight to the ones on this particular topic? Okay, this takes me to but you can then click on the questions in that area if I can find it. Have I gone past it? Organic chemistry, hydrocarbons, yeah. So reactions of alkanes and alkenes. So yeah, and then you can have a go at them and view the answer, which is quite good. As I say, I'm going to find a video as well, which I obviously don't have there yet. So I'll find some quite useful videos, and I'll put them in my database, and I'll also put them there. Where's my mouse gone? I was doing that thing again where my mouse disappears. Right, I'm just going to pause the video and get that going. Okay, so I've actually found some quite good videos, and I've put them in the database actually. So if you just go to the database now, 3 videos. 3 more, well, yeah, there weren't any videos before. There'll be this one that I'm making right now, of course. There'll be 3 videos for alkanes and alkenes. If we go back one level, back to organic chemistry, we should be able to find the one on crude oil. So we're going to the subtopics. We've got cracking, crude oil and cracking. And if we open that up, there should be some videos, or at least one, maybe 2 videos. Yeah, 2 videos. Got fractional distillation of crude oil, and we've also got something called cracking, which I haven't gone into yet in this video. So I'll stop the video there, and I'll save it also in the database, and I'll put it on this board. Okay, thanks. Bye.